Somewhere above you, right now, there is a star you will never see. It is out there at this exact moment, burning the way it has burned for 6 billion years, and it is too faint for your eyes, too faint for binoculars, too faint for almost every telescope human hands have ever built. If you walked outside tonight and stared directly at the patch of sky it occupies, you would see nothing at all. And yet, buried in 4 years of data from a telescope orbiting our sun, someone found that star flickering. The dimming lasted a few hours. It amounted to a fraction of a percent, less light than you would lose if a moth flew past a lighthouse 100 miles away. But it was real, and 385 days later, it happened again, and then again. Something was passing in front of that star, something round, something the size of a world. On the 23rd of July, 2015, NASA called a press conference to explain what that shadow meant. They gave the object a name that sounds like a serial number, because that is more or less what it is. Kepler 452b. The 452nd star system, catalogued by the Kepler Space Telescope, and the letter B, which in the grammar of astronomy means simply this, the first world ever found going around it. Here is what they knew about it. It is roughly 1 6/10 times the width of the Earth. Its year lasts 385 days. It sits about 1,800 light-years from you, in the constellation of the Swan. It orbits inside the habitable zone of its star, the narrow band where liquid water can survive on a surface. And that star is not some alien furnace. It is, in nearly every measurable respect, our own sun. The phrase NASA used went around the world in a single day. Earth's older cousin. The closest thing to a second Earth we have ever found. My name is John. And I should tell you at the very start that this is not going to be the story you think it is. Because we have never seen that planet. Not once. And there are serious scientists who, even now, are not entirely convinced it is there. And the world hiding inside that shadow turned out to be far stranger than a second Earth. It may be a warning. It may be a photograph of our own future, developed across 1,800 years of darkness and delivered to us at the exact moment somebody happened to be paying attention. Let's begin with that darkness, because the distance matters, and it is the kind of number that slides off the mind if you let it. Light is the fastest thing there is. It crosses the gap from here to the moon in a little over a second. It takes 8 minutes to reach us from the sun. It needs about 4 years to arrive from the nearest star. The light that flickered in 2015 had been traveling for roughly 1,800 years. When those photons began their journey, the Roman Empire was still standing. There was no printing press, no compass, no word in any human language for the thing that light was carrying information about. It crossed 18 centuries of emptiness in perfect silence, past cold clouds of hydrogen, past the slow drift of dust, and then it fell into a small silver mirror orbiting our sun and landed, at last, in front of people who knew how to read it. Let me describe the place it came from. Look up, in your mind, at a summer night sky in the northern hemisphere. High overhead there is a constellation shaped like a great cross, or, if you prefer the older way of seeing it, a swan with its wings spread and its long neck stretched out, flying down the length of the Milky Way. The Greeks called it Cygnus. The bright star at the swan's tail is Deneb, one of the most luminous stars visible to the naked eye, and scattered all around it, invisible to you, invisible to me, invisible to every human being who has ever lived and looked up, are thousands upon thousands of stars too faint and too far to register on the human retina. One of them is a star with no romantic name, Kepler 452. It is a dot in a catalog. It is a smudge of light in a data file. Its brightness, seen from Earth, is around magnitude 13, which means you would need a serious backyard telescope and a very dark night just to confirm it exists at all. And it is, in almost every way that matters, our sun's older sibling. Think about that for a moment. Out of the hundreds of billions of stars in this galaxy, most are not like ours. Most are small, cool, dim red dwarfs that burn slowly and glow the color of a dying ember. Others are enormous blue furnaces that live fast and die violently. Our sun sits in a quiet middle place, a yellow G-type star, stable and patient and generous, the kind of star that can hold a world in a steady embrace for billions of years without incinerating it or letting it freeze. Kepler 452 is that same kind of star, a G2 star, the exact same classification we give our own sun, about 4% heavier, about 11% wider. Its surface burns at 5,757 degrees Kelvin, against our sun's 5,778. 21 degrees of difference across 1800 light years. If you could stand somewhere in that system and look up at it, you would see a yellow-white disk hanging in the sky that would look almost exactly like the sun you have known your entire life. Not similar, not approximate. Familiar, but it is older. About 6 billion years old, compared to our sun's 4.5. It has lived 1.5 billion years longer, and in the life of a star, that difference matters. As stars like ours age, they slowly swell and brighten. Kepler 452 has already begun that process. It is a little larger than the sun now, and it pours out about 20% more light. It is our sun, seen from further along the road. It is what our star will look like when the Earth is much older than it is today. And around that star, every 385 days, something goes around. 385 days. Read that again in your head. Our year is 365. This world, 1800 light years away, orbiting a star that is not our star, completes its circle in a span of time almost identical to the one that governs your birthdays, your seasons, your calendar, your sense of what a year even is. 20 days longer. That's all. A world where the year is 3 weeks longer than yours. That is Kepler 452b. And in the catalogs it carries another label, one that tells you it is not quite a twin of our world, Super-Earth. A class of planet that does not exist anywhere in our end, but your order is moving just a little slower than usual. Thanks for hanging in there with us. Now I want to describe it to you, and I want to be honest as I do, because the honest version is stranger and more interesting than the fantasy. We have never seen this planet, not once. No telescope has photographed it. No image exists of its surface, its clouds, its continents, its oceans, if it has any of those things at all. Every picture you have ever seen of Kepler 452b, every lush green world with rivers and mountains and a golden sun on the horizon, is a painting. An artist's dream. A guest dressed in beautiful clothes. What we actually have is a shadow, a dip in brightness lasting a few hours, repeating every 385 days, measured by a telescope that stared at one patch of sky for 4 years without blinking. From the depth of that shadow, we can work out how big the object is, and what we found is that it is about 1.5 to 1 6/10 times the width of Earth. Hold that in your mind. Not a gas giant, not a scorched cinder, not a frozen rock at the edge of nothing. A world half again as wide as the one you're standing on. That extra width does something dramatic. Volume grows fast. If that world is made of rock and metal like ours, it would weigh somewhere between 3 and 5 times what Earth weighs, and that means gravity there would be roughly twice what you feel right now. I have to stop and mark that word, if. Because at 1 6/10 Earth radii, Kepler 452b sits almost exactly on a boundary astronomers have found in the data, a dividing line somewhere near 1.5 to 1 8/10 times Earth's width. Below that line, planets tend to be dense balls of rock. Above it, they tend to be smothered in thick envelopes of hydrogen and helium, small gas worlds with no surface at all to stand on. Kepler 452b is balanced right on the edge of it. The original team put the odds of it being rocky at somewhere around 50 to 60%. A coin flip. That is the honest number. This world is a coin flip between solid ground and a bottomless sky. So let's take the good side of that coin. Let's stand on it. Let me build it for you carefully, and I'll tell you where the science stops and the imagining begins. You arrive. The first thing that happens is that your body understands something before your mind does. You feel heavy. Not crushed. Not pinned. Heavy, the way you feel heavy in the last hour of a long hike. Every step costs more. Lifting your arm takes deliberate intent. If you fell, you would fall faster, and you would land harder, and your knees would remember it. Over months, your bones would thicken. Your heart would grow stronger just to push blood upward against that pull. A person born there would be built differently than a person born here. Shorter, probably. Denser. Stronger in the legs. A different kind of human shape, sculpted by nothing more than the weight of the ground. Now look up. There is a sun in that sky, and it is not a stranger. It is yellow-white. It is the right size. It sits in the right place, and it warms your face the way the sun has warmed your face on every good morning of your life. But it is brighter. Kepler 452b sits in what astronomers call the habitable zone, that narrow ring around a star where the temperature allows liquid water to exist on a surface. It is in that zone, but it is near the inner edge of it. It receives about 10% more energy than Earth does. 10% doesn't sound like much. 10% is everything. Because here is where the story turns, and where a discovery that started as a celebration becomes something closer to a warning. That star is getting brighter. It has been getting brighter for 6 billion years, and it will keep getting brighter. Which means that world has been slowly heating for a very long time. If Kepler 452b ever had oceans, and I want to be careful here, we do not know that it did, then as the star brightened, more water would have evaporated. Water vapor is a greenhouse gas. More vapor means more heat trapped. More heat means more evaporation. More evaporation means more vapor. Scientists have a name for that loop. They call it a runaway greenhouse. It is the process that turned Venus from a possible ocean world into a furnace where lead would flow like water and the pressure would crush a submarine. Kepler 452b may be sitting somewhere on that curve right now. It may be a world in the middle of losing everything, its oceans boiling away into a thickening white sky, its continents drying, its clouds turning from the soft scattered white of a temperate world into a permanent blinding shroud, a world in the long afternoon of its own habitability. And if that's true, then what we found out there in the constellation of the Swan is not a second Earth. It's a mirror, because our sun is doing the same thing. Slowly, patiently, invisibly, our star is brightening too. In roughly 1 billion years, Earth will begin the same journey. The oceans will start to go. The sky will thicken. The blue will fade. It will happen so slowly that no single generation would notice it, and yet it is as certain as anything in physics. So when we look at Kepler 452b, we may be looking at a photograph of our own future, taken from 1800 light-years away and delivered to us by light that spent 18 centuries in transit just to reach the moment where somebody was finally paying attention. Let me sit in that for a second with you. We built a telescope. We named it after Johannes Kepler, a man who died in 1630 having worked out the laws that govern how planets move without ever seeing one outside our own system. We launched it in March of 2009. We pointed it at one small window of sky between the constellations of Cygnus and Lyra, a patch about the size of your hand held at arm's length, and we told it not to look away. For 4 years, it stared at more than 150,000 stars simultaneously, measuring their brightness over and over and over, hunting for the almost imperceptible flicker of a world passing in front of its own sun. Most of what it saw was noise, star spots, instrument drift, cosmic rays, the endless shimmer of an imperfect universe measured by an imperfect machine. That telescope ran out of fuel in October of 2018 and was shut down for good, drifting now in its own orbit around the sun, silent, somewhere behind us. Before it died, it found more than 2,500 confirmed planets. It took a galaxy that we assumed was mostly empty and revealed that worlds are, in fact, everywhere, that there are more planets than stars in the sky above your head. And out of that ocean of noise, in July of 2015, NASA announced that they had pulled something extraordinary. A planet a little larger than Earth, in the habitable zone, orbiting a star like the Sun, with a year like ours. The press called it Earth's older cousin. The headlines went around the world in a day, faster in 24 hours than that light had traveled in the previous 18 centuries. And then, 3 years later, other scientists raised their hands and said, wait. I want to tell you this part, because I think it's the most human part of the whole story. In 2018, a team of researchers went back through the data and asked a harder question. The signal from Kepler 452b was faint. Very faint. It sat close to the edge of what the telescope could reliably distinguish from background noise. And the method used to confirm the planet was statistical. Nobody had ever detected it a second way, with a second instrument. They argued that when your signal is that weak, statistics alone should not be enough to promote a candidate to a confirmed world. They were not saying it doesn't exist. They were saying we cannot be as certain as we claim to be. The NASA Exoplanet Archive did something quietly admirable in response. They didn't delete it. They didn't defend it. They kept Kepler 452b on the list of confirmed planets and added a single word beside it. Controversial. That word is science working correctly. That is what intellectual honesty looks like when it's inconvenient. A discovery that made headlines around the planet, marked with an asterisk by the very institution that announced it, because the evidence wasn't as clean as everyone wanted it to be. More recent analysis has pushed back toward confidence. The odds of a false detection now look small. Most researchers today believe the planet is real, but the asterisk remains, and I think it should, because it teaches something that no perfect discovery ever could. We are looking at the edge of what we can know. Everything about Kepler 452b lives out there on that edge. We don't know its mass, we're inferring it. We don't know if it's rocky, we're estimating a probability. We don't know if it has an atmosphere. We don't know if it has water. We don't know if it has a magnetic field, or a moon, or plate tectonics, or a single molecule of anything that has ever moved on its own. We know how big its shadow is. And from that shadow, we built an entire world. Now here's what I want to leave you with, and then I'll let you go back to whatever you were doing. Imagine, for a moment, that there is something alive on Kepler 452b, not a civilization necessarily, not cities and ships and radio towers, just something. A film of green on the shore of a shrinking sea, a slow thing in the shallows, something that grew, over billions of years, in a heavier gravity under a brighter sun. And imagine that at this exact moment, while you are listening to my voice, something on that world is doing whatever the equivalent of looking up happens to be. They would not see us. Our sun is far too dim at that distance to be visible without a telescope. It would be one anonymous point in the depth of their sky, buried among millions. But if they had built their own telescope, and pointed it at their own small window of sky, and stared without blinking for 4 years, they might have noticed a flicker. A star dimming slightly, every 365 days, by a fraction so small it barely rises above the noise. And they would have written something down in a catalog, a designation, a number. And beside it, perhaps, a note about how the signal was faint, and how they could not be certain, and how the world it implied was smaller than expected, and how they had no way of knowing whether there was anything there at all. They would be looking at us, and they would not know it. The light they would be seeing left Earth 1800 years ago. It would carry no image of your city, your street, your face. It would carry the Earth of the 3rd century, and it would arrive at their telescope as nothing more than a shadow crossing a faint yellow star. 2 worlds staring at each other across 18 centuries of darkness, each one certain of almost nothing about the other, each one reduced to a flicker in a data file. That is the actual romance of this. Not the painted oceans, not the imagined forests. The romance is that we found it at all, that a species that spent almost its entire history unable to explain why the sun rose, built a machine, put it in the sky, taught it to count photons, and used it to detect the shadow of a world it will never visit, orbiting a star it can't see, at a distance it can barely describe. The nearest star to us is 4 light years away, and we have not gone there. We have never sent a human being further than the moon. Every probe we have ever launched, every one of them, would need tens of thousands of years to cross even a fraction of the gap between here and Kepler 452. No human being alive today will ever stand on that world. No human being alive in 1,000 years will either, in all likelihood. And yet we know it's there. We know how long its year is. We know roughly how heavy you'd feel standing on it. We know its sun is like our sun, only older, only brighter, only further along the same path that ours is walking. We reached across 1,800 years of light and we touched something. That's what a species does when it refuses to stop asking. So here is the only thing I'll ask of you. Sometime soon, on a clear night, when you happen to be outside and the sky is dark enough to see the Milky Way as more than a rumor, look for the swan. Find the cross of Cygnus flying down the length of the galaxy. You won't see the star. It's far too faint. But it is there, right now, in that direction, burning steadily, 20% brighter than our own, 6 billion years old and getting older. And something is going around it, every 385 days, whether we're watching or not. It was doing that before anyone here had a name for the sky. It will still be doing it long after the last person who ever heard my voice has been forgotten. Thank you for spending this time with me. My name is John, and whatever else you do, keep looking up.